You're listening to Let's Talk AI.
Okay, so welcome to Let's Talk AI. Today's guest is Sirisha Rambhatla. So, who is Sirisha? Sirisha is an assistant professor at the University of Waterloo in the Department of Management Sciences, Systems Design Engineering, and also cross appointed to the David R. Cheriton School of Computer Science. So, welcome today, Sirisha.
Yeah, thanks a lot for having me on the podcast, Harold.
Awesome. So basically, we'd like to understand. Tell us a bit more about Sarisha. How did this all start? Where did you do your studies, and how did you end up at the University of Waterloo as a professor?
Yeah, that's a long story. So I'll actually start by telling something about myself. Here at Waterloo, I lead the critical ML lab, and where my research focuses on building machine learning models to leverage patterns from data, specifically spatiotemporal data, to address critical applications in healthcare, such as surgery and transplantation, to industrial automation, which can range from like manufacturing floors to like aviations and so on, and also like more fundamental threats relating to explainability and trustworthiness of neural networks and representation learning in general. So now we can go back to the, I guess, how I got started with that preface. My research journey actually began during my master's in electrical engineering at the University of Minnesota, where I worked with Professor Jarvis Hopt. And this was on sparse signal processing on an audio forensic task. So essentially, something like this, where both of us are talking. But let's say we just have a single recording and there are a lot of speakers. How do we actually pay attention to a selective source? So yeah, then it turns out that building this capability in machine learning models to be able to selectively separate out a source is actually pretty hard. So that's how I started. And after my master's, I did go into, I guess, the dark side, into intellectual property litigation, where I actually was able to see very closely how technologies actually change the world. So fast forward, it is now, I guess, end of 2013. And at that time, by that time, I guess deep learning was taking off at that exact time, and I wanted to actually come back to academia. And that's when I did my PhD at the University of Minnesota. And this was, I guess, my time away from academia did make me more mature researcher in that sense. And I delved deeper into statistical signal processing and machine learning and optimization, and developed bio-inspired models, which can with guarantees. So that is how. Um, and at the end of that, uh, it was like, and then like all this is now slowly getting into. And at that time, I guess there is. Um, um, Machine learning or AI consists of people from a lot of different subfields, and so that's how I got into AI.
Okay. Wow, that's I see what you mean. A long story. Okay, that's great. So I noticed in your profile that you run the Critical ML Lab here at Waterloo. What's that all about?
Mhm. So essentially, I would like go back to thinking about at the end of my PhD. So I was doing a lot of theoretical machine learning, building what we call provable algorithms. So algorithms with guarantees. So it's interesting to think about the kind of, at the end of the day, we are solving like optimizations in machine learning. And all these problems are, in fact, inherently what we call non convex. Other way to think about it is we may not know, even you, after you solve a problem, you may not know if you found the best solution, or even how to find that best solution is usually like not known. So this is where I was like doing a lot of theoretical analysis, but at the end of it, I was not really like, it like with the advances in deep learning, it's like this is not the only way we can bring trustworthiness for specifically critical applications. So my lab here at University of Waterloo focuses on building, like leveraging all aspects of theory as well as my experience during my postdoc, which is working on healthcare and surgery and all these kind of applications, and trying to build out uh, trustworthy and reliable solutions. So that's what my lab does here at Waterloo, and this is specifically focused on real world, where a lot of assumptions that we usually have in theory do not hold. So how do you do that? Is like the focus of my work here.
So this whole topic of trustworthiness, I hear a lot of different perspectives on it. Can you dig in a bit more and what is trustworthy, what is non-trustworthy? Where's that fine line? What's that definition?
I think there is no one definition in this, and then which is a good thing in the sense that we are still trying to understand how do practitioners want to use it defines trustworthiness. For example, in my work with university health network here on liver transplantation, we may come up with, and this is with Dr. Mamta Bhatt at University of Toronto. uh, on this thread, we are looking at how do we understand the trajectories of patients who are listed for transplantation. So liver transplantation, and a lot of models that are used and which are like non, uh, let's say neural network based, they're highly like very popular in the area. So practitioners, they actually trust it. Now, when it comes to deep learning, we may develop models which can have better performance, but trustworthiness is I feel like a more human quality, where we need to understand how people would be using a particular technology, and then trying to either via explainability, so understanding how a model is making decisions and conveying that to practitioner, or actually mimicking the practitioner and their decision making itself. So a number of ways to like get to that. But at the end of the day, we are looking at whatever problem we are solving. Is it useful, and is it in line with what we call coherence between humans and how their decision making unfolds, and how models are making decisions, do they align well? So this is I guess a way to think about trustworthiness. Of course, there is different ways in different applications, and it totally is domain dependent. Yeah, I guess that's why what also makes it pretty exciting.
So does trustworthiness, do you think, vary based on the sector of application? For instance, trustworthy on the health side versus, say, on supply chain. Or are they similar, or where are they different?
Oh, that's a very good question. I do think it depends on the area. Mostly, I guess every area they have some tools and techniques they rely on, and the experts who actually look up to these things. So whenever we bring on new models, and this is actually goes back to one of the courses I teach here at Waterloo, is how do managers make decisions, and how do we connect that to like AI and machine learning? Is that humans in general are like they don't like making huge changes. So when we go, there is a huge human side here when we go to application area, is to think about like what is, how do they currently make decisions, and how can I, when I build a particular model, um, how can I align it with them, and what kind of metrics would they like to see to build trust and trustworthiness? Yeah, so it's I guess definitely dependent on the application. For example, as I said, for liver transplantation, they use what we call as survival analysis models, and so whatever we build, we do have like proper baselines and reproducibility and all those kind of things which can build trust on. we have another very active thread with NAFBlue, which is an Airbus company, and it looks into. We are actually combining two areas here: operations research and machine learning. Very exciting, very new in terms of how machine learning is branching out into real industrial applications. And here we are trying to see. We essentially will have baselines, and again, we will use explainability. What is the model actually relying on? Are these features something that practitioners actually use? Is something surprising? How can we dig into that? And to actually make airline operations more um, based on like evidence-based research, I would say, because at the end of the day, there's so much uncertainty, and definitely COVID has appended a lot of that. Uh, they end up doing things manually. So, which is, I guess, uh, somewhat exciting and also like somewhat scary on how these people have amassed so much experience. How do you build that same experience into models? So yeah, do building trust in models, coming back to the point, is dependent on the area, and we have to talk to experts, and we have to speak their language essentially, and convert whatever language the model speaks into something that uh, they can appreciate and actually use. So, and then this is not meant in the sense of essentially we are building models which would be helpful uh, to them based on what they tell us, instead of saying, hey, this is what I built and you should now use it. So that is the like change in how I like think about problems when I talk to like experts, and to build, um, I guess, more trustworthy models.
Okay, this sounds like you're really blending in the human side, and that's exciting to hear that's happening. So, I first actually met you a while back on an opportunity related to applying ML to supply chain and things like that. Could you, and then again, I guess that overlaps with your work in the management science. Could you give us a little more insight into that?
So my work, in fact, looks at like spatiotemporal um, time series and data analysis. And this appears in a lot of different contexts. It can be climate, it can be healthcare, it can be like when it comes to COVID, you can think about like misinformation and all these threats. So when I came to management sciences, it is like a very I would say a very unique department where we bring in experts from like almost social sciences and organizational behavior to operations research and information sciences, and I belong to the information sciences division there. And the main thing I will give you an example of NAVBlue itself. Uh, in the aviation industry, and how we like combine operations research and machine learning. So in the aviation industry, for example, um, peop there is a, I guess, a bunch of people who would come up and say, okay, this is a schedule 4 months from now. Now, if you can like, if you think about that, we don't know what all will like change during that 4 months, and we don't know what the weather will be like on that day, and all the other things. So they come up with a schedule, and and every airline does it, and they agree upon specific time slots and so on. But on the day off, they have to manage like crew. They have to manage the aircraft itself, its maintenance, and costs and fueling costs, and so many different things. So on the day off or the day before, somebody calls in sick. Somebody like, and you can think about COVID and how that, like even like Toronto International Airport, and how the situation has been over like past few years. Somebody calls in sick. Weather is like has of course is a huge factor there, and or the aircraft itself. You're waiting for the aircraft. There is some delay in the network somewhere else. It may not be even local to Toronto. So they, in fact, do it manually. Sometimes they even have to do it manually, like to schedule things out. And uh, in some cases, they may have to think about, hey, I will then like fly at a higher altitude so that like my like I can go at a higher speed, or so on, or or lower altitude or higher speed or whatever that is. So in the end, they end up spending like more fuel, and even one disruption can like negate whatever like the profits that a airline has accumulated for in the past few weeks. So there are so many different factors here. Um, and there is a scheduling aspect, which is the operations research, and that is essentially in our project. It is led by Professor Fatma Gazara, who is like a leader in that area, and I lead the machine learning front, where we think about, let's forecast different aspects, let's forecast for delays, let's forecast for based on what has happened in the past, can we kind of minimize these kind of disruptions. So this is all data driven. We look at historical data, and uh, then we try to come up with and then feed it into an optimization problem, which is like the scheduling part. And these can also be done together. This is like a very, very new area. I've seen like in the past 1 year that has taken off, this combination of like operations research and machine learning. So these data driven things, and it's such a large scale, and thinking about like all these networks, how they influence each other is um, it's somewhere we see in like industrial applications or manufacturing or supply chain similar problems. So uh, yeah, that's what the work has been on that front.
Wow, this is exciting because everyone only experiences it as a passenger, and they hear their flight's been canceled and or postponed, and now it gives you some context as you've explained it, what's going on behind the scenes. Okay, so you did touch earlier on. Sorry, I did touch earlier on the critical lab. Is this a broader team you're working with, or others? You did mention one or two other professors you're working with in this space. Could you elaborate further there?
Oh yeah, for sure. This lab, I lead the lab. I am the director of the lab, and this is, but I do work with a lot of people at Waterloo. So, for instance, I do have projects on across Waterloo. If you think about uh, the other threads, there is one with a lot of threads with the vision and image processing lab at the systems design engineering. So, Professor David Clausey, Alex Wong, and uh, Paul Figet and John Zilick, we work on multiple threads. One of them is with Nissan AI and Mobility Lab in Japan, and this is on human pose estimation, where we like got significantly good results, like 38% improvement over state of the art. And this is like over, I guess, a few months ago. And another with like again with the WIP lab is Stat Leads. It's a sports analytics company. So we are now uh, they're analyzing ice hockey, and I'm not like I'm not an expert in sport at all, but I look from a point of view of time series and how like you can think about these players as graphs and how they're evolving, and at that abstraction, I guess. Another interesting things that are developing with the WIP lab is our collaboration with Grand River Hospital, and this is we are actually starting with bias and fairness. Like, is it, even before we build a model, we need to understand, are there pre-existing biases in the data by humans which the model may learn and then propagate? So how do we actually think about it before we start doing anything else? So that's also starting recent, like in like next few weeks, I would say. And yeah, another other than that, uh, there are always, I guess, new things which I not really can talk about at this point. Oh, you never know. Uh, but it's a lot of different things, and very, very extremely like busy, but very exciting as well, on how Waterloo offers all these avenues to branch out. So, although I lead my lab, all my students are working and collaborating with a lot of different people across the university.
And how many students do you have in total?
So I think as of last week I had four, but this week I think I have five masters, and I informally mentor a PhD student in the WIP lab. and I guess undergrad research associates. Yeah, it's a pretty big endeavor, I guess.
Is yeah, very busy. So you mentioned when we're just in your last description there, fairness and bias. Is there an overlap, I guess, with fairness and trustworthy? I mean,
Oh, absolutely. Yeah, you touched upon a very good thread there. Um, I guess there is, in fact, it goes back and forth, I guess, because when we start off, we can say, how are the model making decisions? And then you find out that the models are relying on protected attributes. And then you can actually think about, hey, is that biased? Is that something that I want to learn? Um, or is my model making, and a lot of times, it's also uh, the area itself. I'll give you an example. Uh, in liver transplantation, uh, the size of the liver matters a lot. So uh, that means that like someone like me, who is like fairly petite, would be clubbed in with children for liver transplantation, and I would actually not have the same preference or priority to receive a liver transplantation. In fact, the group which is so when if I just said, hey, the weight matters for liver transplantation, people usually would think that lower weight or something like that is like it's highly correlated, but it is in fact um, higher weight probably has you have better chances of receiving liver transplantation. Now, this is just based on like just data, um, because just for like I will like from the point of view of if I am petite, then of course someone younger to me, like who is a child or like a teenager, would definitely receive a high preference for in the order. So I'm disadvantaged at that a point, but if I find this in the data, I'm not surprised everyone knows about this. So there are certain policies which may impact a particular type of preference structure. But there are a lot of times where these biases are not even like more implicit, and the practitioners may not even know about it, and that is where it becomes a more like a policy issue, where we say, is there systemic bias against uh, certain groups that we should not be propagating? That was unintentional. um, and that is where the distinction comes in, and knowing for example in the liver transplantation examples, the existing methods for interpretability just give you hey, this feature is important. They don't tell you the polarity. Is it like supporting transplantation, or is it like not supporting it? So for instance, it would just tell you weight is important, and then somebody might interpret that as lower weight or healthier, whatever is like new fad is better, but that is actually not true. um, and so knowing, so interpretability kind of helps us see which way it is actually biased, or which way are like how do things actually impact the outcomes. And interpretability is deeply tied in with trustworthiness. uh, of course, trustworthiness is a higher bar, but that is like a building block towards trustworthiness. uh, so yeah, these kind of things actually exist across in different like application areas. You'll see it differently, um, and that's what we have to be in tune with. And yeah, so that's how these two things are related.
okay. Well, thank you for this kind of journey through this trustworthy and fairness and bias aspects. It's a good insight for us. I'm not sure we've had any other of our participants in Let's Talk AI have talked about that, so it's really good. Well, I think I just again want to say thank you so much today for joining us for Let's Talk AI. And Sirisha, I just want to say all the best in your research as you move forward.
Yeah, thanks a lot again for having me. I would just also like to give, although it has only been like, I guess, 1.5 years here, I'd like to just thank all the Waterloo community here, specifically UW and Circ group, who helps a lot with grant writing and also engineering research office. Yeah, thanks a lot to them, I guess. And yeah, thanks a lot again for having me, Harold. It has been a pleasure talking to you.
Excellent. Thanks. Have a great day.